to sets and Venn diagram. So these are terminologies that we are going to be explaining in this topic, which our first one is sets. After set, we're moving to elements of sets. Then we're going to move to empty sets, infinite sets, universal set, subset, union set, intersection of set, complement of a set, and cardinality or numbers of sets. Now let's move to the first one, which is set. Now what is set? Set is the collection of well-defined objects, in the sense that we use sets to collect things that are like together, such as if you look at this country now, we have a country can be a set whereby we have all the states in a country. Those are what, like Abuja, you can have your Kano and other states. So this means like as if you have collected all likely things together, such as, like I said earlier, I said this A now will stand for a set of a country, so whereby we are going to have all elements under it. So the elements are going to be like the states in a country, meaning that the elements you collect together in a set, they are what, they will be familiar, and then they're going to look the same. Such as if you have your a set B, let me use B. A set B can be fruits. So all fruits we have, they're like apple. You can have your apple here, you can have your pineapple, and all other fruits, etc. and all other fruit. And a set is denoted by a curly bracket. This bracket is actually known as curly bracket. So set, in summary, set simply means when you collect all likely terminology or likely elements together. So that's what we call sets. Element of set is the next one. Now, what are the elements of set? Like I said earlier, I said if we have set A, which represents a country, whereby a country has what, a state, such as like Abuja, based on what I said earlier, Kano, Lagos, and others. So the Abuja here, Kano here, Lagos here, they represent the elements of sets. And take note of one thing: if you are given questions like this in exam, and then they want to give you the element of set, they will give you in this format by saying if your set A is like this, and the element will be like a small alphabet, such as small letter A, small letter B, C, D, and so on, F, and so on. So these A, B, C, D, E, F, G, and so on, they represent the element of the set. And it cannot be written like this. After writing set A, then they should not write A here, B, C. So this cannot be possible, because these elements here, they have to be written as small alphabets. And also, they can also give you element of set in figures, such as 1, 2, 3, 1, 2, 3, 4, and so on. So anything you write here inside this curly bracket, they represent the element of set, which it can either be this or this. So it cannot be capital letter. So that is what we call element of set. Empty sets. From the word empty, empty means nothing. So this particular empty set is denoted by this symbol, ordinary curly bracket, or you write this symbol. So this symbol actually represents empty set. Empty set means empty set, they are set that does not have any element. So whereby if a set, let me say set A now has no any element, or maybe if they write this thing for you, maybe in your question or exam, and they only put by saying set A is this or this, they are trying to refer you to that this particular set has no any element. So therefore it is an empty set. And empty set can also be called a null set. So either you call it empty set or you call it null set. Whenever you see this symbol whereby written as 0, which is cancelled, or ordinary curly bracket, that represents an empty set. It's a set that does not have any element in it. So that's an empty set. Now let's move to the next one. Some call it infinite, some call it infinite set. From the word infinity, if you have a set, which is what they said, okay, all natural numbers. And remember that all natural numbers, they are counting numbers, the number that you can count, starting from 1 to what? Infinity, that is no ending. So this type of set, whereby the element has no ending, so that's what we call infinity set. Probably you can also call it an uncountable what? An uncountable element. So any element that does not have any ending is called infinite set. Another example is if they tell you, okay, all multiples, no, all counting numbers, yes, all counting numbers like 1, 2, 3, 4. By the time you continue writing, when you get to 1 million, you will keep writing. So this type of set is an infinite set. A set whereby the element does not have any ending, like the word uncountable, whereby we still keep counting, and it does not have any ending. That's an infinite set. Firstly, universal set is denoted by this symbol. Some write it like this, while some also write it like this, something like this. So some people used to copy it here or somehow, but I like writing it like this. So this is a universal set. Universal set means is a set that comprises of all the elements, such as, like, giving an example, if you have a country, let's say set A represent a country, like I've said earlier, and in the country, we have 36 states. So these 36 states will represent a universal set. Instead of me writing this A like this, then I'd rather write it like this form. So this symbol denotes a universal set. Wherever you see this symbol or something like this, whereby they will curve this place somehow, then we say this is a what? Universal set. It comprises of all elements of that particular set. Like this symbol, universal set, giving us that it comprises of all the 36 states in the country, in Nigeria. So 36 states in Nigeria, you can have your Abuja, you can have your FCT, Kano, and all other states we have in the 36 states. So that's the universal set. After this, the next one we are going to have is a subset. Now look at this subset. A subset means, like as if you are saying topic and subtopic. So this universal set is going to stand as if it is a topic, which the topic is what? Set and Venn diagram. Why this subset is like as if we are deriving it from where? From universal set. I repeat, a universal set of this symbol. Let's say universal set is 1, 2, 3, 4, 5. Yeah. So, and they say, okay, what are the subsets we have from this universal set? Like I said earlier, a subset means like something like subtopic. So a subset A, we have like 1, 2, 3. And also you can have your subset B as 2, 3, 4. Also you can have subset C as what? 4, 3, and 5. So meaning that you can have a single universal set with a lot of subsets. Subset is written like this. This symbol only stands for universal set, while capital letter A here, capital letter B here, capital letter C here, they represent a subset, something like a subtopic, whereby universal set will represent the topic. So these are examples of a subset. A subset is derived from universal set. Like now, if I should come here now and write comma 6 here, meaning that I have violated what subset is all about, because 6 is not among the universal set. So all elements in this subset will not go beyond the universal set, and that is what we call a subset. What we'll be looking at now is intersection set and union set. Let me combine the both together. Firstly, the symbol of intersection means this. This symbol represents intersection, while this symbol represents union. So let me explain this very well. Giving you that, let's assume they give you a universal set as what? Let's say it is A, B, C, D, E. And we are given a subset A of what? B and C. And you're also given a subset B as what? Let's say we are given a subset B as A, D, E. So we are now asked to find A intersection B, meaning that we are asked to find A intersection B. Intersection means what is common between what? Subset A and subset B. So from here now, looking at subset A and subset B, there is no any number, there's no any alphabet common between the both. So what would I write? I will just come here and write it as an empty set, meaning that this particular set did not have any elements. I repeat, in intersection means what comprises this set A, subset A, and this subset B together. Look at the elements we have here. We have B here, but B is not here. We have C here, but C is not here. Likewise, all the elements we have here, they are not here. So, and I said intersection means what is common between the both sets. Whenever it's intersection, then you look for what is common between the both. So, since there is nothing common to the both, then you are going to represent your set as an empty set. So now, looking at union, if you are asked to find A union B, union can simply means combination of the two sets together, meaning that when you combine the both set A and set B together and then writing it alphabetically, That means from ascending order. That means from the smallest to the what? To the biggest. So writing this thing from smallest to the biggest is going to be A will be here, B, C, D, and E. So this particular answer, that is the answer for union. Again, union means combining the two sets together. A union B means you want to combine set A and what? Set B together. And when you are writing it, you're going to write it in alphabetical order or from in ascending order. So let's assume if I have D here, and I was told to find the A union B, how would I go about it? I'll write my A here, which is this. I'll write my B here, which is this. I'll write my C here, which is this. Then coming to the D, I have two D here. What would I do? I'll just pick only one. So I'll pick only one. Then I'll come here to write my E. So this represents A union B. And A union B is this A, B, C, D, E for this particular set. Now let's move to the next one. Let's look into complement and cardinality of sets. Starting with complement first. Complement is denoted by this symbol, something like this or something like this. So I can actually write subset A, so a complement, which is A complement, or it can be A prime. So you can write a complement as this small letter C, just this small c, or you denote it as well, a prime like this. Now what is complement? Now let me explain this using an example. Given a universal set of 1, 2, 3, 4, and 5, and we are given a subset A. Subset A will have to come from this particular universal set, such as what? 1, 2, 4. Let's assume our subset A is 1, 2, 4. It has to come from this universal set, and we are told to find A complement. So what will be the element, or what will be the member of A complement? The members of A complement will be, it will mean that what is in the universal set that is not in the what? In the subset A. Meaning that after removing this 1 from here, 2 from here, 4 from here, then what is left in this universal set? That is going to represent the complement of A. That is A complement. And that is going to be just ordinary 3 and what? And 5. Because from here, 1 is here, 2 is here, 4 is here, why 3 and 5 are not here? So A complement to represent is going to be 3 and 5. You can also write it like this, A prime. A prime also means the same thing as complement, and the element for A complement, or the members of A complement, will be 3 and 5. So that is complement. Now let's look at cardinality. The cardinality, they can ask you, the symbol for cardinality means small letter M. That means cardinality. Look at this guy now. Small letter M means cardinality. Some people might call it number of sets instead of calling it cardinality. If they call it for you numbers of sets, that means you represent it as small letter N. So any one of the two, they means the same thing. So let me call it number of, or let me call this cardinality of set this time around. Cardinality of set and number of sets means the same thing. Now what does it mean? If you are given to find the cardinality of this particular universal set, like this universal set, now you are asked to find the cardinality, or they can call it find the number of this universal set. So what will be the answer to this? You will just come to this element you have here and count them. That is going to be what? 1, 2, 3, 4, 5. Then you will come here and write 5. Mind you, writing 5 here will not be in the curly bracket. Just write your 5 like this. The same thing with number of universal sets. This is a universal set. Then how many numbers do we have here? 1, 2, 3, 4, 5. You will just come here and write 5. This terminology means the same thing. Either you call it cardinality or you call it number of a set. Now, if you ask to find the number of this A complement, the number of this A complement will just be what? 1, 2, and that's just going to be 2. Or probably they tell you it is cardinality of A complement, and that is going to be ordinary 2 as well, because cardinality and number means the same thing by counting it as 1, 2, and that is going to be 2. So example 1 says, given that the universal set is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Then we have a subset A. Remember that subset A is removed or derived from universal set. So subset A is subset A is 2, 4, 6, 8, 10. Why subset B over there is what? 1, 3, 5, 7. Remember that Y subset C is 1, 2, 4, 5, 6, 8, 9, 10. The subset A, subset B, and subset C, they are all from universal set. And mind you, you can have more than 2, 3, 4, 5, 6, 7, 8 subsets. It can be subset A, subset B, C, D, E, F, depending on how the question comes. So the real question now says, these the members. Remember that the word members also means elements. So whenever you see members, it's still the same thing as elements. And the symbol for element is this. So whenever you see this symbol in mathematics, it represents what? Member, or you call it element. So list the members of the following sets. Now A says A union B. Union means we are combining the set in A and B together. So whereby we're going to arrange it alphabetical order or from ascending order. So A union B is going to give, now in this set B we have 1 here, so I'll write 1 comma, then we have 2 here, then 2 will be here. Is there 3? Yes, there's 3, so I'll write 3 here. Then there's 4 here, I'll come here to write 4. 5 is here, then I'll write 5 here. We have 6 here, I'll also write 6. We have 7 here, I'll write 7. 8 here, I'll write 8. Then no 9, but we have 10, so I'll come here and write 10. So I'll close the curly bracket. Curly bracket, curly is spelled like this, curly bracket. So these are the what? These are the members or elements of A union B. Now let's move to the next example. Next example says A intersection C. Remember that intersection means what is common between the element of what? Of subset A and subset C. So what is in A that is also in C? So now let's check. In A we have 2, we have 2 here too. So 2 is common. That means 2 intersect C. So we have 4 here, also we also have 4 here. So 4 is among. Then we have, is there 6 here? Yes, we have 6 here, we also have 6 here. So 6 is among. We have 8 here, we also have 8 here. So 8 is among. And we have 10 here, we also have 10 here. So 10 is also among. So these are the members or elements which represent this symbol of A intersection C. That is what is common between subset A and then subset C. Next example we'll be looking at is A union B intersection C. Now let's look at this. This one is like as if we are combining 3 subsets together: subset A, subset B, and subset C. So how do we go about it? Yes, firstly, we are going to firstly work on this one that is in the bracket first, which is B intersection C. So B intersection C will give us what? Let's check. Intersection means what is common between what? Between the subset B, the element of subset B, and the element of subset C. So what is common there? Okay, 1. 1 is here, and 1 is also here. So we have 1 here. Let's check. 3 is here, but no 3 here. That's out of it. 5 is here. 5 is also here. Then we write 5. Then 7 is here. No 7 here. So we only have 1 and 5 as the element of B intersection C. So we will now say, okay, A union B intersection C. That will now be what? It simply means that the answer we got here when we intersect B and C together, which is 1 and 5. So we are going to union it with A. That means these two answers we got here, 1 and 5, which represent this, we are going to union it with A. And union means combining this together with what? Subset A. So the element we have here, we are going to combine it with this. But ensure that you write it in alphabetical order or in ascending order. So writing it now, union means combining. So writing now, we're going to write 1, because 1 is the smallest. Then the next one will be 2. After 2, okay, I have 4. Then after 4, I have 5 here. Then after 5, 6. After 6, then 8. After 8, then 10. So now these are the elements or members of A union B intersection C. But what if they now ask us that, okay, what is the cardinality of A union B intersection C? Or they call it number of A union B intersection C. That means you just come over here to count all the elements we have here, which is going to be 1, 2, 3, 4, 5, 6, 7. So that will just give you ordinary 7 for the numbers of A union B intersection C, or cardinality of A union B intersection C. So the example D now that we have says A intersection B union B intersection C. So let's take it one by one. A intersection B. A intersection B is going to give us what combines. We want to combine this and this together. We want to intersect rather. what is common between A and B, and that is going to be nothing. So nothing, because 2 is here, no 2 here, 4, 6, 8, and 10. So we have it as empty sets. A intersection B gives us an empty set. Now, what about B intersection C? B intersection C, okay, now let's intersect this and this together. We have it as 1, 1. So 1 is common for both. 2 is not common. 3 is not there. 5, you have 5 here. And what again? That's all. So we only have 1 and 5. So then we're now going to say, okay, we want to union this and this together, meaning that we want to combine nothing and 1 and 5 together and arrange them alphabetically. So A intersection B union B intersection C. So that will just give us what? By combining this and this together, this means nothing. So meaning that our answer will still be 1, 5. So the elements we have for A union B, A intersection B union B intersection C is just 1 and 5. Example 2 says, if the universal set is small letter A, B, C, D, E. Remember, these are the what? Elements or members of universal set. And the subset A is A, C, E. Subset B is what? B and what? E. Subset B has a member or element of small letter B and small letter E. Then we are told to list the members of the following sets. A complements. Now, like I said earlier, I said complement means what is in set A, like what is a universal set that is not in set A. You can see we have A here, C is here, but B is not here. And also E is here, while D is not here. So A complement is going to be, this is a subset A, this is a universal set. Let's compare. We have A here, we have A here. We have C here, we have C here. What is not here? Which is B. So B, comma, we have E here, we have E here, but D is not here. So B and D, they are the complement of A. If they should ask you what is the cardinality of A complement, or what is the number of A complement, and that's going to be 2. By counting these elements we have here, 1 and 2, and that's going to be 2. Now looking at B complement 2, that's what the subset of B. Subset B has elements of B and E. So what are the complements? When we compare it with this universal set, B is here, whereby B is also here. Why A is not here? So A will come first. Then B is here. Let's ignore that. C is here, but it's not there. So C will be here. Then D is here. Y is not there. Then D will be here. Why E is here is also there. So we are going to end it with just ACD. So ACD is the what? Is the complement of subset B, which is B complement. Now let's now move to A intersection B everything complement. What I'm going to do is that we firstly look at A intersection B. So if I should come here and say A intersection B will give me, let's look at A and B together. What is common to the both? We have A here, A is not here. We have C here, C is not here, but we have E here, which is also here. So A intersection B will give me E. So then after writing this E, what are we going to do? We're going to find the complement. The complement of this, we are going to complement it with what? Universal set. So if I should complement it with this, that will give me A intersection B complement. So if I should complement it with that, meaning that I will check what is this element E. I will compare it with this universal set because I'm trying to look for the complement. So that will now going to be what? That means if I should underline this and this now is out of it. So I have these remaining 4 letters or 4 members. So my answer here will be A, B, C, D. So A intersection B complement is going to give me A, B, C, D. And if I'm asked that what is now the number of A intersection B complement, or the cardinality of A intersection B complement, and that means by counting this number here, which is going to be 1, 2, 3, 4, and that is going to be 4. Now moving to the last question, which says A complement union B complement. I already have it here. I have my A complement here, and I have my B complement here. So what would I do? I will just union the both together. Union means I will combine the both together. So, but when I'm combining it, I will make sure that I write it in alphabetical order or ascending order. That means from smallest to the biggest. So I have my A here, which is going to be here. I have my B here, which is the next. C is here, which is the next. Then I have D, which is 2, meaning that I'm going to pick 1. So picking 1 here, I'll just write it here. So I have my answer should be A complement union B complement gives me A, B, C, D. Example 3 says, if X is a member of universal set, remember this symbol. This symbol means member. So if X is a member of what? Universal set. That means X is part of universal set. And universal set is just numbers from 1 to 10. So the question asks us to list the members of the following subset of universal set. Meaning that all the numbers, all the answers we want to write now, they should come from this universal set. Meaning that whenever all answers I'm going to write now, they should not go beyond this universal set, because we have been told to list the members of the following subsets of what? Of the universal set. Now let's start from the first one. A says what? A says X such that X is an odd number. So if I want to list the members of the odd number, remember that it has to be in curly brackets. So the odd number I'm going to list must come from this universal set. And what are they going to? What are the odd numbers we have there? That's going to be 1, 3, 5, 7, and 9. So those are the odd numbers we have from this universal set. And B says that I should list the member of what? Of X such that X is less than 7 from here. Such that X is less than 7. So from here now, what numbers are less than 7? That means I have it from 1 to 6. Because 6 are less than 7. So that is going to be 1, 2, 3, 4, 5, 6. So these are the members. This C says that X such that X plus 2 is greater than or equals to 7. So how would I know the members for this particular answer here? So I will start by saying X plus 2 is greater than or equal to 7. Then I'll collect my like terms by saying X is greater than or equals to 7 minus 2. And that is X is greater than and that is X is greater than or equals to what? 5. So remember, are they being so the members of this particular answer is going to be, they said X is greater than or equals to 5, meaning that X can be 5 or greater than 5. That is what this thing is trying to explain to us. X can be equals to 5 or greater than 5. And from this, remember I said our answer must come from this universal set. So we are told that X is greater than 5 or equals to 5. That means X can be 5. So 5 will be here or greater than 5, which means I'm going to have 5, 6, 7, 8, 9, and 10. Yes, so these are the members you are going to have for this particular answer to this question C, which is going to be 5, 6, 7, 8, 9, and 10. And the last one, which is the D. The last one, which is the D, says that what? X such that 3x minus 2 is equal to 9. I will firstly solve it first by saying 3x minus 2 is equal to 19, rather, not 9. This is 19. So I'll now collect my like term by saying 3x equals to 19 plus 2. So 19 plus 2, that is 21. So I'll have it as X is equals to 21 over 3, and that is 7. So remember that I said X is equals to 7, and 7 is among these universal set. So the answer to this will just be ordinary 7. X is equals to 7. This does not have greater than, neither does it have less than. So I'll just write my answer should be X equals to 7. And the members are going to have here, it will just be ordinary 7. So that is that. This is a practice question for you to do. So which question says that if universal set is 1 to 10, you are given a subset, A should be 1, 2, 5, 7. Subset B should be 1, 3, 6, 7. So you are asked to write down the set of the following, which is, the first one is A complement. You write the answer for that. The element for that. B complement, you write down your answer. C is what? A intersection B complement. You write the answer down. And the last one is A union B complement. Remember that this C and the D, they are in brackets. So you have to work on the both together before looking for the complement. So this is your practice question. Work on it. Venn diagram now. We are done with sets. Now Venn diagram. In Venn diagram, example 1 we are treating says in a class of 35 students. So 19 take history and 12 take economics. Then we are told that if 5 take both subjects, then how many take neither? meaning that how many did not take neither of the economics nor the history. Remember that Venn diagram, Venn is usually used to represent, this diagram is usually used to represent sets. Yes, it is the man called John Venn that work on this diagram. So he tried to represent any set in form of what? Form of diagram. So now let's work on this example 1. So example 1, working on Venn diagram, the first thing to do is to draw your Venn diagram table. Venn diagram table. Now this is the table. Then question says in a class of 35 students, that means the total number of that class, total number of the students in that class, they are 35. So remember that I said the word total means universal. So our universal set here is going to be what? 35 students, which is going to be here. Then he said 19 take history. We have two subjects there, which they are what? History and what? And economics. So that means the set is going to be this one for the history, while this one for the economics. E and C. Sorry, H and C. H and E rather. So H is representing history, while E is representing economics. So now they said 35 students are the total number of students in the class, while 19 take history. So I'll come here in the history and I'll write 19 here. Please don't do any mistake by writing the 19 here. You just have to write it here. That is how to represent this information in form of Venn diagram. So, and we proceed by saying, and 12 take economics. So the economics here, they are just 12. So 12 will be here. Good. And if 5 take both subjects, remember both means combination. That means 5 people take both economics and what? History. So we have 5 here. That means 5 people out of the 35 takes both history and what? And economics. Then we are now say how many students takes neither of the two subjects. That means how many students did not take neither of history nor economics, meaning that those students did not take either economics or history. So how do we proceed by solving this thing? I've already meaning that neither, I can use it as what? Let me use it as y. So which is going to be here. So y is there. Okay, because neither, you know, this all this box, all this circle rather, this circle means for history, this circle means for economics. Why this whole square, this square shape means that everybody here, they are what? They are 35. Because this one means all the students are here like this. That's how Venn represents sets. That's how Venn is the name of the man that work on this diagram. So now what are we going to do? We're going to look at those. This 13 comprises of those that took history together with what? Together with economics. Now let me show you something here. Look at this bracket now. This bracket here, as I've seen it here now, as I've seen this thing now, everything means 19. Why this one you are seeing here like this, everything here means what? 12. Meaning that out of this 19, 5 is among. Out of this 19 here, 5 is among. So, but for we to have those that will stay here on this spot only, whereby this 5 will not be among, that is going to be what? 19 minus 5. So 19 minus 5 is going to give us what? That will be 14. So 14 students only took history. 14 students only took history. Look at the word only. Please note my word. The word only. Note this word. Note this word. Only. Only. So 14 students took only history. Now what about this economics? They're going to say for we to know those that will take only economics, there will be what? 12 minus 5. And 12 minus 5 is going to give us 7. So 7 students only took what? Economics. 12 students took economics. Why 5 took both history and economics, whereby 7 is just for economics and 14 is just for history. So the next question now we're going to do is okay, who are those that do not take any of the subjects, which is known as how many takes neither of the subjects. Remember that I said when we add every numbers in this together, it gives us 35. So that is going to be the 14 we have here plus this 5 we have here plus this 7 we have here. Remember that this 19, I've analyzed this 19 by saying 14 and 5, and I've analyzed this 12 by saying 5 and 7. So I don't need to tamper with this 19 anymore. Likewise, this 12 anymore, because I've already analyzed them here. So then I'll have my 14 year, I have my 5 year, my 7 year, plus this particular y, which is going to give me 35, because all these people come together to constitute that 35. So 14 plus 19, 14 plus 5, that gives me 19. So we have 19 here plus 7 plus y equals to what? 35. So this plus this, that gives me 26. So y, if I collect my like terms, that gives me y equals to 35 minus 26. I've already summed up these values together by saying 19 plus 6 plus 7, that gives me 26. So by the time I collect my like terms, then I will have my y should be what? My y is going to be 35 minus 26, and that is what? 9. So meaning that 9 students did not take neither of history nor economics nor the both. So they didn't take any of the subjects, and that is the 9 students we have here. So going back to the question saying that how many take neither of the subjects? So we have 9 students takes neither of the subjects, because if you subtract 35 away from 26, we are going to have 9. So 9 students take neither of the subjects. So the last question which I'm going to be looking at under this Venn diagram is this example 2, which says a school sport team contains 68 students. 33 do field events, 40 do track events, 23 do swimming, 40 do both field and track events, 8 do both swimming and field events. If 15 do field events only and 10 do both swimming and track events, how many students do swimming only? That's the A. B says track events only, and C says all the 3 events. Now look at the Venn diagram. I'm trying to illustrate all these questions in a Venn diagram before we start solving it. Yes, please take note of this work very well, because there are questions that they'll be asking you in your exam. Probably you're writing your further mathematics exam, or probably you're writing your mathematics exam in WAEC, even in neco, in nabteb, or any other exam you're writing. Take note of this particular question very well. Now let's go with the solution. A step-by-step solution is what I will explain to you now. Please watch this video very well, and if you have any question, don't hesitate to ask the question under the comment section, or if you have any other question you want to give to me, maybe in mathematics or in chemistry, just don't hesitate to ask me the question. And if you need my number, you just see it on the screen. Look at the number displayed on your screen. Just text me on WhatsApp. I will actually going to reply you. Or probably you need questions, you need explanations rather on chemistry or mathematics or further math, engineering math, business math, any of the mathematics, including any of the aspects in chemistry. Don't hesitate to text me on WhatsApp, or probably you send a mail to our email address, which is mathchemtutorial@gmail.com. So now let's dive into this question. Yes, now look at this particular box and here mean that we have 3 boxes here. We have 3 circles. Let me call it circle. We have 3 circles here, the first one, the second one, and the third one. And attending to the question, now let me read the question again to your hearing. We said a school sports team contains 68 students, meaning that our universal set is going to be 68. So universal set here is going to be what? 68 students. So because we have all the students that offered, that do the sports, yes, all the teams we have, they are what? They are 68 students. So our universal set is what? 68 students. Now let's go in. They said 33 do field events. 33 do what? Field event. Let me represent this guy here. This guy here as what? As F, which means field event. While 40 do track event. Let me write this guy here as T. While 23 do swimming. Let me write S here. So X representing swimming. Then they said if 33 do field events. Remember that don't write the 33 here. Don't write the 33 here. Just have to write it here. So write your 33 here in this place. What can only make you to write the 33 here is when they said 33 do field events only. whenever they put the word only, they said 33 do field events only, then you can now write the 33 here. But because they did not put the word only there, please don't write it here, write it outside. Okay, let's proceed. 40 do track events. So here we go for 40. Don't write 40 here. Don't write 40 here because only is not there. They said 40 do track events only. Then you can now come here to write your 40 inside this place. Okay, and they said they said 23 do swimming. Okay, we have here should be what? 23 do swimming. Okay, now they said 14 do both field and track events. 14 do both field and track events. Field and track event, that should fall where? Field and track, that is here, isn't it? Field and track is there, but did they put only? No. 14 do field and track event, but only is not there. So you can just come here and write A intersection, that will be F intersection T. So F intersection T gives what? Gives 14. Yeah, F intersection T gives 14, but not only. They put the word only there, then you can just come here and write your 14 here. Well, you can leave it like this, or probably you just write it as cardinal number of F intersection T anyhow. So number of F intersection T gives us 14, or you write cardinality. If I change this thing to M here now, that means it's giving me as what? Cardinality of F intersection T, and that is what? 14. Then let's proceed. They said 8 do both swimming and field events. 8 do both swimming and field events. Swimming and field, that is going to be here, be spotted here. Field and swimming. So I will write it as number of what? F intersection S. So number of F intersection S, and that give me what? 14 do 8 do both swimming and field events. Swimming and field event. You can write it as F intersection S, or you can write it as S intersection F. Anyone. It still means field and swimming, the same thing as swimming and what? Swimming and field event, and that is what? 8. So I will write 8 here. Then they said if 15 do field events only. Now look at this condition. They said if 15 do field events only. So now we have been told that 15 do field events only. So I will come here and write my 15 here. So we have my 15 here, meaning that only field is standing for 15. So 15 students do field events only. Okay, so it's here like this. Then the last one they said, and 10 do both swimming and track event. 10 do both swimming and track event. So swimming and track event, this and this. So that will be here. It will be spotted here. So I will still write it as the number of swimming intersection track event, and that is what? That is 10. So now the question now said, how many students do a swimming only? That means you are asked to look for what is going to be here. That is swimming only. And also track event only. That is what is going to be here. And lastly, all the 3 events, what is going to be on this place. So here is what we are looking for. Here and here. These are the 3 questions we are asked to do. So how are we going to start? Now look at this now. You said this F intersection T, F intersection C means here. Please take note. And also this F intersection S means this particular thing. So 8, like this place, F intersection S goes for this, while S intersection T goes for this. So for you to solve the question number 1, we say swimming only. Let me advise you, we cannot solve swimming only first. It will not be possible. So what we're going to solve first is to look for all the 3 events. Now let's see. For me to look for what is going to be here, remember that normally I meant to write this 14 here, this 8 here, and this 10 here. but because this thing they are not in only, I told you that whenever they didn't tell you that they are in only, so don't write it here, just write it out. Just write it out like this. So the only here is, let me represent this first one, this particular one as x. Let me take it as x. So now for me to have this guy here, which is f intersection s, which is 14. This 14 actually means that the guy here on this spot plus the guy here, that's the meaning of this 14. 14 means those people that take this f and t only plus those that take all the three. Remember, all the three means this 14. So for me to remove all this guy here that take all the three from this 14 will give me what is going to be here. Again, for me to remove this guy x here from this 14 here, actually give me what is going to be this only for this f and t, which is this spot. So that's going to be, for me to have the only of this, that will be 14 minus x. So what is going to be here will be 14 minus x. And for this f intersection s, which is this spot, so what is going to be here is 8 minus x. So here will be 8 minus x. So 8 minus x will be what is going to be here. Let's assume x is 3 now. 8 minus 3, 5. 5 is going to be here, because 5 will be the only for this one. It's going to be the only. Those that take f, those that do f and s only will be this 5. That will be here. Why assuming that if x is what 3, but we don't know what x is yet. And for this last one, this place now, which is s intersection t, which represent this, and that will be what 10 minus x. So all this value, they are what supposed to be here, and maybe we know the value for x. So now, having known this place should be 14 minus x, and here should be what 8 minus x. So I will sum up this value plus this value plus this value plus this, everything here. Remember I said it gives me 33, because they are all representing f, but not in only. So the value here plus the value here plus the value here plus this gives me 33. So that is going to be 14 minus x plus 14 minus x something here plus this x, I mean this value here, plus 8 minus x, what's supposed to be here, plus this 15 here. So everything will give me 33. So solving this one, plus cancel minus, plus s cancel minus x. So I have it as 14 minus x plus 8 plus 15 equals to 33. So 14, now let me collect my like terms, and that should be, and that is going to be minus x equals to 33 minus open bracket, okay, 33, okay, let me write it one by one. 33 minus 14 minus 8 minus 15. I can actually put it in brackets like this. Change this one to plus. It still mean the same thing, because when you multiply minus times all this plus, it will still give you minus. So minus x is giving me 33 minus, so 14 plus 8, that is 20. Oh sorry, 14 plus 8, that is 22. Then 22 plus 35, that gives you 37. So I have here should be 37. So now minus x is giving me 33 minus 37, and that is going to be what? That's going to be 4, minus 4 rather. So minus x equals to minus 4, and when you divide the both sides by minus, you have the x should be equals to 4. So having known that x is equals to 4, that means this value here is going to represent 4. So what we have here now is 4. From here now, I can now change all this value now. So 14 minus 4, that gives what? 10. 8 minus 4 gives what? 4. 10 minus 4 gives 6. So I can actually write all these guys here now. So here now I have it as what? I have it as 10. Here now I have it as what? I have it as 6. While here I have it as 4. Why this x? Let me clean it and let me write it as my 4 that I got here. So now let's proceed. So with this now, I've gotten the answer for this C. That C says all the 3 events. So 4 students took all the 3 events. Now what about swimming only? Swimming only means this particular place. I'm asked to do for this place. So how would I do it? I will say let me represent this guy here as y. So I will say 4 plus 4 plus 6, everything minus 23, and that will give me this y. So to get this swimming only, let me write it here as only swimming. Only swimming will be 23 minus when I sum up this y, this value here, plus 4, this 4 here I'm referring to, plus this 4 that is here, plus this 6 here. So then I can now do the arithmetic by saying 23 minus, 4 plus 4, that is 8. 8 plus 6, that is what? 14. So y plus 14. So that will be equals to 23 minus y minus 14. If I collect my like terms now, then I can have it as, okay, this one, that will be y equals to 23 minus 14, and my y will be equals to around 9. That will be 9, yes. Y will be equals to 9. So that means the value here is going to represent what? 9. Let me clean it and let me write it as 9. Yeah. So now the last one, which says this is for swimming only. Then now I have the last one should be track event only. The track event only, which is this. Remember that addition of everything here. Let me represent this place as, let me say it is a z. So addition of 10 plus 4 plus 6 plus this z will equal to what? 40. So for track events only, so that will be 40 equals to, well, if I should add 10 plus 4 plus 6 plus z, so that gives me 40. So from here I can actually say 40 equals to this plus this, that is what? 20 plus z. So looking for my else, so collecting my like terms, that will be 40 minus 20 equals to z, and the z is going to be 20. So meaning that those that took only track events, that is going to be 20. So I can actually come here and write 20. So with this we have answered all the whole question. 9 students took only swimming, 15 took only field events only, while 12 students took only track events, whereby 4 took both field and swimming only, 10 took both field and track events only, and 6 took both track and swimming event only, while 4 took all the 3 sports, which is field event, track event and swimming. Now this is a practice question for you. The question says, in a class of 50 students, 30 study biology, remember there is no only there, and 25 study economics, not only in that one too as well. So 15 study neither biology nor economics, meaning that in the brackets, in the diagram, so the 2 circles are going to have, this 15 will not be among. That means this 15 did not take neither the biology nor the economics, but they will be inside the what? Inside the square, but not in the circle. So the question now said, hey, how many take both subjects? How many take both subjects? That means the intersection. Those that took both biology and economics. And B says, how many take biology only? Note that word only. And the last one says, how many take economics only? So note that word only. We practice that question.